Okay, back again with the, let's see, this one's the August 2016 exam. So we'll go through the open response starting with 25. This question right here, there's a couple ways to do this, but the main concept that you start with is tangents to the same exterior point are always congruent. So what they're telling us is AC to CE is in a 5:3 ratio. So these two right here. Well, whatever AC is, that's congruent to BC because AC is a tangent, and so is BC. So tangents to the same exterior point are congruent. Okay, those are the same. And then, of course, CE and CD are the same. And we don't know, well, they tell us they can't be. AC is not the same as CD. They're going to be different. So if AC and CE are in a 5:3 ratio, then so are BC and CD. All right, so that's basically what we get. BC to CD must also be 5:3. All right, so what I like to do is they give us the entire B to D at 56. If this is in like a 5:3 ratio, I like to say 5x and 3x, meaning we're going to multiply them by something. Whatever we multiply by, it's going to be the same. So for me, what I like to do here is we want CD, right? Okay, so if we want CD, what I might do is something like this. 3 is to 8. Now, it's 3 equal parts from C to D, but it's going to be 8 equal parts all the way from B to D. So you kind of get that 3 to 8 ratio, okay? Now, we don't know how long CD is. Let's call it Y. And we know BD, the whole thing, is going to be 56. This is just one way to do it. I like setting up the proportions for these type of problems, so we'll do that. Okay, so whatever 3 times 56 is 168, divided by 8, and Y is going to be 21. So there's CD. All right, next one. Let's see. All right, so we're just going to perform, looks like a sequence of averaged motion transformations. So translate 5 right, 2 up. So there's B prime, C prime, and A prime. Okay, and then what we're going to do is a reflection over y equals 0. Okay, so y equals 0 is not the y-axis. It's actually the x-axis. All the y values on this axis are 0. So that's why that's the definition of that equation. So B is going to end up 1, 2, 3. So we're going to go perpendicular and the same distance. So there's B double prime, perpendicular and the same distance. A double prime and same thing. 1, 2, 3. And there's C double prime. All right. Now, graph and label is all they said. They didn't say state the coordinates, so you don't really have to. I'm going to write them down. All right. So we've got 6, negative 3 over there. So if you're going to do this, make sure we don't make a mistake here. That's 9, negative 3, and C double prime looks like 9, negative 7. Whoops. And let's just make sure that makes sense. 5 to the right, 2 up. That's 6, 3. Yeah, so that works. All right. Let's see. A regular hexagon. All right. So here's what we could do right here for this one is, let's say we had a circle. Regular hexagon would be 6 equally spaced out points. And that would make a regular hexagon. And what I like to say here is, if that's point A, if we rotate it this way, how far would we have to go so that every point would have a corresponding point that it matches with on the regular hexagon? Well, it's 360 degrees all the way around. Okay. Now, if there's 6 equally spaced points, we can divide by 6 and get 60 degrees. So every 60 degrees, you will map the figure onto itself, or it's called rotational symmetry, however your teacher has taught you that. Okay. So it's 60-degree rotational symmetry about this center point, and what they're looking for is 60 degrees. Okay. And okay, compass and straight edge, what we'll have to do is I'll start here, but then I'll have to go over to Geometer Sketchpad to finish this. Now we want the median to segment AB. That simply means we've got to find the middle of AB, but using constructions, don't just guesstimate. And then the median is going to connect from the vertex C to the midpoint of AB. All right, so that's a median. How are we going to do that? Okay, we're going to construct the perpendicular bisector, because you can do that, perpendicular bisector of AB. Okay, now wherever that hits, okay, wherever that intersects AB, that's going to be our point. Let's just call it, what, M? Sure, we'll call it M. And then C to M is going to be the median. All right, so we'll head over to Geometer Sketchpad. Okay, so here we are. Let's try to make this appear to be a compass tool. So what we're going to do is we're going to put the center of the compass tool right there on B. We're going to pick a radius that is going to be, it's going to make us 2 circles, one centered at B, one centered at A, that are going to overlap. Okay. Now, if we use the same, so we're going to construct that circle. Okay. Now, if we put the center of our compass tool on A and use the same exact radius, okay, what we just did was these 2 points are the same distance from A and B, okay, because we used the same radius. So we're going to construct that line. Now, this is the perpendicular bisector line, okay? That's not the median. The median is going to be found, the median is going to be found when we find this location right here and connect it to C. All right, so that is going to give us our median. So right there, that's our median, and that's how you perform this construction. All right, so let's get back over to this. All right, let's see, we're going to have a rotation centered at Q. All right, angle N is 57 degrees. Put that in there. Oh, angle L is 47. Okay, so if we're using a rotation, what we can tell you is that corresponding angles are going to be congruent, because that's a, congruence transformation, or better, the term they want to see is probably rigid motion transformation. So corresponding angles will be congruent. Of the image and pre-image. Triangle MNP. So corresponding angles of triangle MNP will be congruent oh wait, sorry, let me do that again. Corresponding angles of triangle MNP will be, and triangle JKL will be congruent. So that's going to be our explanation, basically, okay, when we get there. Now, what does that mean? Well, angle L and angle P must be corresponding. So angle L is going to be congruent to angle P. So I can put 47 degrees up here at angle P. All right? So that's the first big idea. Now, what I'm going to do is, the next big idea is, I'm going to add 57 and 47 to get 104. And 180 minus 104 is 76. So the measure of angle M is 76 degrees. And you're basically saying because the angles of the measures, the three angles of a triangle, must add to 180. So there is 76 degrees left for the measure of angle M. Okay, that's not the greatest explanation in the world, but that'll do it. Okay, that'll get us the credit that we need, and then that's your answer, so make sure we box that in. All right, number 30. Okay, now with an open response question, they did not provide a graph on this question, so it's kind of implied that they want an algebraic solution. You're not allowed to go over the scrap graph paper. We cannot score that scrap graph paper. We're not allowed to. So it's implied that we've got to do this algebraically. Now, the way to do this algebraically is to understand the equation of a circle in center radius form is this right here. This is center radius form for the equation of a circle. Now, we've got to get to that point. We've got to write the equation of the circle that has this center and radius. So here it is. So for this particular one, we're going to say it's x minus 1 squared. Okay. Basically, you know, it's always this, what's in this parentheses is always the opposite sign of that one. So then it's y, and now it's going to be plus 2 squared. Okay. Now you're seeing the center is at 1, negative 2, but you're noticing these signs are the opposite signs. It's because when you plug in 1 there, you're going to get 0. You want the center to give you 0. So when you plug in the center, you're going to get 0 on the left side. Now that's going to equal 4 squared, which is 16. So that is the equation of our circle. Now, here's the concept. If the point is on the circle, the point substituted into the equation will be true, meaning you'll get 16 over here because that's equal to 16. So you want that equation with the point plugged in to be true. Of course, if it doesn't work, then it's not. So here's what we're going to do. We're going to plug 3.4 into the equation for x and 1.2 for y. And we're going to ask ourselves, is that in fact equal to 16? So 2.4 squared is 5.76. That's 3.2 squared. What is that? 10.24. And again, it's really a question mark. Does it equal 16? Add those together. It does. So this is a true statement. Okay. Therefore, the point 3.4, 1.2 is on the circle. I guess so the answer is yes. Okay, so that's your justify your answer. So that's kind of what we're doing there. All right. All right, this one looks like a basic trig problem, right triangle trig. If you look at the acute angle and the right angle here, we're going to end up using right triangle trig. Okay. Now, this is the hypotenuse, so we like to label the sides. Compared to the 75-degree angle, this is the leg that's opposite, and this is the adjacent leg. All right, opposite, we want the ladder. Okay, the ladder is the one what's leaning, so that's going to be the hypotenuse, and we get the 15 feet for opposite. We should be using sine. All right, so sine of that 75-degree angle should equal, we'll call it x. Oops. 15 over x. All right, what is sine of 75? Okay, we got that out of the calculator. It's going to be 0.965926, and it keeps going. Now, I like to put that over 1. I like to, teach my students look at the sine function is a trigonometric ratio of two sides. So make it a fraction. Okay, so then we got 15 over x on the right side, and now we can get the cross products. 0.9659 times x equals 1 times 15. All right, so we're going to divide by that and let the calculator do its work. It looks like 15.5 is the closest. It's about 15.5. So ladder is about 15.5 feet. So there it is. All right, another compass, straight edge, dilation. Okay, so what is a dilation? We're going to look at the center, B. So B prime is going to stay there. The center of dilation doesn't move, so that is B prime. And here's what we're going to do. We're going to take our straight edge, and somewhere along here is the path for A prime. I don't know where it's going to land. Somewhere along here is where C prime is going to land on. Just use your straight edge. Now, if it were negative, if the scale factor were negative, we could go through this way, but it's positive, so I know I don't need that. Now, how do we get the exact location? Well, what we're going to do is take our compass tool. We're going to put the center of the compass here. And we're actually going to measure that. Okay? We're going to get that distance. Then we're going to slide our compass center up to here, and we're going to copy that same radius, and we're going to put it right there, and that's where A prime is going to be. We're going to do the same thing. Center of your compass tool here, right? Strike an arc through C. That's basically your work shown. You have to show your work. And then you're going to put the center of the compass tool here, and you're going to do the same sized arc. That's going to be C prime. Now, what should happen, if I did this correctly, A prime, C prime will be parallel to AC, if I did this correctly. So let's go over to Geometry Sketchpad and see it a little better. Okay, so we're back over here. Here's what I want to do right now. I want to take my straight edge, and I want to construct a line. Now, because B is the center of dilation, A is going to lie somewhere on that line. Now, because it's a positive scale factor, it'll be in this direction. So really, I could have done just a, I could have made it just a ray. But let's get this as dashed. Okay. Now, so somewhere on here is going to be A prime. Same thing here. I'm going to take this. Somewhere on this straight path is going to be C prime. Now, let's get the exact location here. Okay. So I'm going to take my compass tool, put the center of it right there, and I'm going to pick a radius that's going to pass through A. So I'm going to construct that circle. All right. You won't construct the entire circle, probably, with yours, but I'm going to show that. So really all you have to do is you kind of have to draw an arc that's about this big. Okay, just show you measured from B to A. Now what we're going to do is we're going to put our compass tool on A, and we're going to repeat that. Circle by center and radius. Okay, right there. So what just happened was my dilation, my scale factor for the dilation is 2. So I doubled the distance from A to B. Okay, so you want twice that distance. That's where A prime ends up. Okay, I'm going to do the same process over here on C. Now, It's going to get a little confusing. All right. Let me just, I'll pause it for a second and I'll get that scaled down some. Okay, back again. Now, what I did was I just got rid of what, the extra so you could see this better. Basically, all you need is the arc. You just need enough of this arc to show that you measured with your compass tool from B to hit A. And then again, you need enough of this arc so that you can show that that's where A prime belongs. We're going to do the same process over here, okay? So from B, center of your compass tool through C, you're going to construct that circle. Okay, that's just proving that you measured with a compass tool and you didn't just estimate. Okay, so now we're going to do the same thing. Put your center of your compass tool at C, use that same radius, and that's where C prime belongs. Now, if we had a scale factor of 3, we would just do it again. Make it 3 times as long from B to C prime. So right here, you have our image. Let's make those actually thin. Okay. And of course, you've got a label. Make sure you call it A prime. And, of course, the other one is C prime. So, good enough? All right, coming back over here after we've got this labeled and all the work shown and everything, describe the relationship between the lengths. Okay, be careful of the lengths. So, here's something I do. I like to use this equation, pre-image times scale factor, all right, equals the image. This is one way to go. Now, the pre-image was A to C. Now, times 2 for the scale factor equals the image A prime C prime. Okay, so you could say the image A prime C prime is twice as long, or twice the length of AC. Okay, showed some work, you explained, and we're all set. Okay, so what I'll do is I'll stop there and I'll leave the rest for the next recording. Thanks so much. Go ahead and subscribe and like the page.